Alright folks, going forward, one of the important things that you have to understand about additive manufacturing or 3D printing is the term slicing. Okay? It's a common term in the industry, and what it essentially means is going from or taking a design model that you create in 3D. Let's say that you design in some software a cylinder with a hole in it. Well, there has to be some magic that happens that goes from a 3D CAD model to turn that into a printed part, what is called a real part. Okay? And that magic is the slicing plus the machine that does the printing. Okay? You see, the machine that does the printing is nothing more than a tool. It is essentially a CNC machine, a CNC type machine, computer numeric control device. And what's happening is that this machine needs information about your CAD model to actually make part layer by layer by layer by layer, this part right here. And so slicing is the process of converting this CAD model into computer code instructions for the device to work off of. Now the reason we call it slicing, however, is because of this. Additive manufacturing builds up something layer by layer, right? You know, we don't cut it away, we just build it up. So one little layer at a time. So what happens though is, let's say we're talking about a cylinder, is that the printer has to print one layer of the cylinder first. Then it prints the next layer on top of it. And the printer needs to have commands to tell it what to do. So the printer needs to know, I need to go this far. Let's say we're doing some kind of box, okay? The printer needs to know, I need to go this far in the X direction, this far in the Y direction, this far in the X direction, and this far in the Y direction. And then I need to do it again. And then maybe I need to turn around and make some kind of zigzag pattern inside this part, all while turning my motors on to actually extrude out material, or turn my heaters on to heat that material, or turn my laser on to solidify that material. So you have one set of components that are telling it to do things in the X, Y, and Z direction, move motors, change directions, change speeds. You have another set of instructions telling heaters and electrical equipment to turn on or off. And you have other instructions that are involved with other steps associated with the work. You have maybe a heated bed that's turning its heaters on too. So all this stuff is what we refer to as G-code. And that's an important term for you to know with this process. G-code is the actual code that the printer is following to execute a print command. Let me give you an example. Here we go. This is an example of a G-code set of instructions. Now just so you know, all the stuff that you're seeing right here at the top is actually information that is more for the user, not for the machine. I can tell that by the fact I see a semicolon. Whenever a machine reads a semicolon, it ignores what follows it. Now every bit of G-code is one line at a time. So the machine's not starting to do anything until it starts to see things like this. Okay, look at this. X-7, Y85, F1000. That means something to the computer. It even says, this is what's happening. It's the slow wipe command, and it's actually telling it to wipe the nozzle. Now we're going to move on down, skip some more, and here we're starting to see the meat and potatoes. First of all, it executes a G90 command, an M82. And then it starts doing these steps. G1s, X17s, these are all positions. Then it tells it to do something like turn on the heater, stabilize the heater, get it ready to go, and then start executing some movement. See these values right here? These are actually statements associated with position on the printer bed. So the X coordinate of whatever it's doing is 130.875, the Y coordinate is 157.644, and an E factor, which is not Z, is actually a separate setting. Now I don't want you to spend a lot of time worrying about what's happening here, okay? Because of the fact that you don't need to understand G-code, okay? You don't need to be able to necessarily read G-code at this point. All you need to know is this. This G-code is a very, very, very long set of instructions. And this is actually a fairly small part. Its only build time is about 1 hour and 31 minutes. It's not a very big part, but you see how many lines of code are to be generated. Now, get me wrong, back in the day of early CNC, somebody used to have to code this stuff manually. Now, we have computer software that looks at the CAD file and writes the instructions out for the printer, which is one of the reasons that the system and the concept of additive manufacturing is so more accessible now than it used to be, is because we have good coders out there to write the code, or good slicers out there to write all this G-code. So anyway, that's the G-code, and you've seen this example of it here. It's actually just a Word text document that you can see pretty easily, and that is what's telling the printer what to do. Every time it turns the extruder on and heats at a certain temperature, that's because the G-code told it to do that. Every time the extruder goes to the right or the left, or turns on a laser, or raises the heat bed, or whatever the case may be, it's because the G-code told it what to do. So for us, we need to learn how to use a slicer to write the G-code for us. We can then turn around and put the G-code into a printer. Here we go, putting it into a printer. And we get a part as a result. Now, what do you need to make the slicer work? Well, you're going to need some software that does the slicing. We're going to take a look at that. You need a design file, a CAD file, typically an STL, although many slicers can handle multiple file types, such as OBJs, and there's even AMFs coming out, or in more production now, and other types. But the most common, by far, is still typically the STL. So you need a CAD file to bring it in, or an STL file to work with. The slicer is going to write the G-code, and you need to get the G-code to the printer to make the part. All right? There, in essence, is the sequence of events that we have to follow. So we'll take a look at the next video and pick out a particular software. The reason we call it slicing is because the slicing program is writing code for every layer. So layer 1 has its own set of codes. Layer 2 on top of it has another set of codes. Okay? So what the slicing program is actually doing is it's taking your 3D model and it is virtually slicing it and writing a code for each slice. That's why when we say slicing, that's literally what theoretically is happening. It looks at your object, your CAD object, per sliced layer and writes the code for each one, and then just says execute all these slices. So terminology slicing. How many slices does it design the part into? Well, that depends on how big, how tall essentially the object is, and your layer height. Layer height controls how big the slicing settings are. So for example, if the unit was 10 units tall and you had your layer height set at 1, then it would take essentially 10 slice commands to do this, or slicing sets of instructions. If your part was set to a height of 0.5 layers, or layer height, then you're going to have to do 20 slice settings. Now, you don't actually ever see this. All you do is tell it how tall your layer height needs to be, and it figures all that stuff out there for you. But that's why they call it slicing, because it looks at the CAD model and breaks it down into slices and writes a code per each slice layer. Okay? Alright, we'll see you on the next one.